Understand the concept of entropy. Entropy is a thermodynamic measure of the positional disorder and the number of microstates, possible arrangements, available to a system. Generally, entropy increases, delta S greater than zero, when a solid transitions to a liquid or a liquid/solid transitions to a gas, since gases have far greater freedom of motion and spatial distribution than condensed phases. A chemical reaction results in an increase in the total number of gaseous particles. Large molecules dissociate or decompose into a larger number of smaller individual particles. Conversely, entropy decreases, delta S less than zero, when a system becomes more ordered, such as when a gas condenses into a liquid or solid, or when the total number of free-moving particles decreases. Analyze option A. Before shows 4 diatomic molecules, X2, clustered in a gas-like distribution. After shows 8 individual, separated atoms, X, dispersed throughout the container. Process, chemical bond cleavage/dissociation, X2 gives 2X. Since the number of independent gas particles doubles, from 4 to 8, the positional disorder and microstates increase. Thus, entropy increases, delta S greater than zero. Analyze option B. Before shows a highly ordered, tightly packed crystalline lattice of atoms at the bottom of the beaker, representing a solid phase. After shows those same atoms widely separated and distributed randomly throughout the entire volume of the vessel, representing a gas phase. Process, sublimation/vaporization. X gives X, transitioning from a highly restricted solid lattice to a highly dispersed gaseous state significantly increases positional freedom. Thus, entropy increases, delta S greater than zero. Analyze option C. Before shows 4 triatomic molecules of type ABA with a black central atom and 2 white terminal atoms. After shows 4 diatomic molecules of type A2, white-white pairs, and 4 separate individual black atoms. Process, decomposition reaction. 4ABA gives 4A2 plus 4B. Because the reaction starts with 4 gas molecules and produces 8 independent gas particles, spatial disorder increases. Thus, entropy increases, delta S greater than zero. Analyze option D. Before shows 5 triatomic bent molecules, such as H2O, dispersed randomly and moving freely throughout the container, representing a gaseous or liquid state. After shows those same 5 molecules clustered together in a highly organized, tightly packed localized arrangement at the bottom of the vessel, representing a crystalline solid state. Process, condensation or freezing, X, G/L, gives X. Because the molecules lose their translational and rotational freedom of motion and are locked into a highly structured solid arrangement, the number of available microstates drops dramatically. Therefore, the entropy of the system decreases, delta S less than zero. This identifies option D as the correct answer. The correct answer is option D. Visual, option D.